Hello all, welcome to my YouTube channel. So in today video we are going to discuss on Docker, what is Docker and how it works. So basically we are going to create a series on Docker where I will basically cover from beginner to advanced level topics about Dockers. So let's start. So what is Docker? Docker is an open source containerization platform by which you can pack your application and all its dependency into a small unit called container. So basically you whatever the need or whatever the things your application required to run, you basically are packing everything so your application can run on any of the platform. Think of it like basically a lightweight portable box that holds all the requirement which your application need to run. It could be your application libraries, dependencies, your application code, and the runtime which application required. So everything basically you are packaging into a box, and you are just passing that particular box to the operation team, and they can run your application in any of the operating system. Either it could be a Windows, Linux, or Mac, based on your requirement basically, obviously. So Docker majorly use containerization, which means your application will run in all the environment when wherever you pass that particular box or the container, or I would say the image. It could be your laptop, it could be your server, it could be on a cloud, like whatever platform it will be basically run your application. So why we need basically containerization? Because in what happened nowadays, earlier, I would not say nowadays, earlier basically without previous the containerization, suppose a developer creating an application and he's testing their application on his laptop and it's working fine. As soon as he passed the application code to the DevOps team or operation team, for example, there the application code is not working, so there is always a miscommunication, or I would say there is some tension, like okay, this code was working in my system but it's not working in your virtual machine or in your cloud environment. I don't know what's the issue. So to avoid all such kind of issues, basically the we use a containerization, so everything will be in a single packet, and that packet basically you can run on any of the environment. It could be your dev environment, QA environment, test environment, prod environment, it could be anywhere, but your application will work it like that it was working in the developer system. Similarly, it will work in all the virtual machine or in all the cloud platform. So this basically help us to basically it will I would say the deployment of your application makes easy with the help of container, because you are not going to change or modify any extra thing for your application to run. Everything is inside that particular box and you are just executing that particular box. So now the point come, when we already have a virtual machine concept, then why we need a container? So the difference is, when you set up a virtual machine on any of the hypervisor, then what's the architecture of virtual machine? Like you have some kind of hardware or maybe a big servers, then you install a hypervisor over there, then you create a virtual machine. Maybe you need 2 3 4 or a number of virtual machine based on your hardware capacity, but each virtual machine will have their own operating system, then own libraries, own applications. So they are not lightweighted, they are basically mostly heavy, because if you see, whenever we install any operating system, that operating system itself consume around 20 to 30 GB of your system resources, or I would say space. So it become a very heavy, and it is not easy to move the virtual machine from one environment to another environment. That's why the containerization introduce. And in containerization, basically you have the infrastructure the same which we have in virtual machine as well, the hardware, where you basically you install your operating system, but here we don't have any kind of hypervisor. Virtualization is happening here also. In virtualization, in containerization, it is now, I would say it's now virtualization in terms in container is called a containerization. Here we have a single operating system on your server, and you have a container engine which is called a Docker engine. Yeah, in short form we also call Docker D. And on a container engine, basically you are creating a multiple containers, and those containers basically doesn't have their own operating system. They share the operating system from the host operating systems. That's why they become a very lightweight, because they only need whatever they require. They need only application code, they need the runtime, they need the dependencies, they need the libraries. That's why it easy to it's become a portable, so we can easily move from one environment to another environment. So this is the major difference between containerization and virtualization when it comes to the virtual machine and container parts. Now let's understand the Docker architecture. So Docker basically use a client server architecture. So if you can see, this is the client part and this is the Docker daemon, or we would say a Docker engine. And again, here we have a Docker registries from where basically we will push or pull the Docker images which is required to run our application. So in client side, basically it is possible to install a Docker client and server on a same machine, and you can also use Docker client and Docker server in a different machine as well. So Docker client basically talks to the Docker daemon, which is Docker host, and it will basically communicate over the REST API, over the Unix socket, or a network interface, I would say. And whatever the part, what are the heavy part, basically creating a container, deleting a container, running the container, all these things execute or perform on a Docker host or Docker engine itself. The client machine just gives the instruction what needs to be done, and Docker daemon do the things for us. So the lifting and shifting of your container, creating, deleting, building, everything will perform on a Docker host itself. So whenever, suppose you have created a Docker file in your client machine and you run that particular Docker file, and you have provided the multiple instruction on that particular Docker file, and you want the very first thing, you want image, or I would say a base image, which is required for, which is the basically a mandatory part of any of the Docker file. So that basically the base image, we will pull it from the Docker hub or Docker registry, and rest all the instruction which we have passed, like creating a folder, copying the code, everything will be done on Docker host. So the image pull will happen from the registry, and rest all the instruction will be performed on a Docker host machine. So basically client side, you are just passing the instruction to the Docker engine, and Docker engine is doing everything whatever it needs to done, basically as per your configuration file, whatever you have written over there. Now there are few key components of Docker. So the very first is Docker engine, which is the core part of Docker that handle all the management tasks for your containers, like in terms of creation, building, deletion, running containers, execution of containers, everything will be done on Docker engine. Now the another core component is Docker image. So basically Docker image is your read-only template that is used to create a container, which basically contain the application code and its all the dependencies. Now the third important component is Docker Hub. So Docker Hub is a cloud-based repositories that is used for finding and sharing the container image, whatever the base image we specified on a Docker file, that is pulled from the Docker Hub itself. So there are almost most of the things you can find on Docker Hub, but still there are few requirements which is not fulfilling from the Docker Hub images. Then you can also create your own custom image as well. Now the Docker file, which basically help us to create a Docker image. So Docker file is a script file where we write all the instruction what needs to be done to build a Docker image. Now Docker registry, as soon as, like, when we create a Docker image, then we need a central location where we can keep your image, we can keep our images. So that's come out Docker registry. So Docker Hub is a public repositories, and there also you can create your private registry as well, and there are other registries as well. For just for example, in Azure we have a Azure container registries, and in AWS we have a ECR. So there are many public cloud registries also available. So based on requirement, you can utilize those registries as well. Now, why we use Docker? So the very first or important, consistency. So whatever the application code you have written in your system, it will work in all the environment wherever it will go. Portability. So Docker containers run basically on any of the system. It could be your local laptop, virtual machine, cloud. So it is easily portable. You just have to pull the image and it will create a container for you. Efficiency, because containers are most lightweighted because they doesn't have their own operating system. They need minimal operating system which is required. So and you can run multiple containers on a single machine, and the resource utilization you can also customize based on your requirement. Collaboration, teams can share the Docker image. So basically, for example, if you have created a one custom image which is required by multiple teams, so they don't need to waste their time to create that particular Docker image again. They just simply pull the Docker image from the Docker registries and they can utilize in their project. So these are the few I would say use cases or the features of Docker, which is basically help us to for easy from software development to deployment. Now there are few real world use cases where we can utilize or where we can use a Docker. So the very first thing is web application development. Second is microservices architecture, which is most popular nowadays. Third is CI/CD process. When we automate our deployment process, that time also we can utilize a feature or we can utilize a container. So these are the few real world example. There are few, basically there are many more where you can utilize a tool called Docker and you can containerize your application. So that's all for today. It was a very basic introduction about Docker and then how it works. So see you next video. Thank you so much.